Morning, ladies and gentlemen. Lecture 10, we're in double digits, and happily we're going to stay in double digits till the end of this semester. We have about 30-something lectures. Announcements. If I can get this to move, which is my usual problem. Right. Project 1, your first fairly longish data analysis exercise is going to be released during the next lab. It is where you will examine water usage data in California, and you look at incomes by zip code through taxation data provided by the IRS, overlay, and see who's using water and who isn't. And so part of the reason for these what you're going to see in today's lecture and Monday is getting you ready to be able to handle moving stuff around in tables and so on, so that you can do the analysis that you want to do. We will suggest some things that you ought to do, and those things you can follow line by line. But you will then have access to a lot of data, and you might want to mess around with it, and hopefully we'll give you tools to do that. Now, it is all very well saying Project 1 is going to be released if every time you try to get hold of something, it says 502. So we're working on that. I think one of the issues has been that as people do more stuff and submit more stuff, space is getting used up, and then it has to be cleared. And Sam Lau, one of our GSIs, is working hard on getting that set up. So it will be smoother, though it is a much bigger operation than we had anticipated, even given last time's experience. So I apologize for the frustration of trying to get on and not being able to. I think you know that your homework deadline was pushed back? Yes? To when? Today, exactly. So, it's, hopefully we are going to settle down. And certainly the enrollment is settling down, I'm happy to say. I will not describe John De Niro as a guest lecturer. He is a co-instructor in this class, and he will teach next week on Monday. And I'll do some table methods today. He'll do another lot on Monday, and he'll do the part of the fun stuff. You are going to be drawing lots of maps in your projects. So there'll be, this water district and that IRS district and so on and so forth. And so one of the things he's going to be doing is showing you how to draw maps. So please come. He is a fantastic lecturer. I think his reputation is all over campus. Don't miss that one. I am very grateful to the 469 students who filled out the survey. The data have been used. Yeah. I'm thinking about whether 469 is equal to 475 or not. But the data are going to be very useful, and what can I tell you about? I gave you some summaries. Those summaries didn't change very much since we last met, and so still half the class thinks that they have no skills or bad skills or terrible skills in programming. Almost 2/3 of the class doesn't have this as a requirement for anything. 52% of the class are female, 48% male. What else do I have? There's a vast number, as we saw, I think, in one of the previous classes, different intended majors, all kinds from all over campus. You are a diverse and very interesting group, and based on the survey, 2 people in this room have today as their birthdays. Either of them here? There's one. All right, so ladies and gentlemen, this is going to happen more than once through the class, not always with the same song, but I am going to pretend to conduct very badly, and you are going to not pretend, you're going to actually sing, however well or badly you can sing. So, for our student whose birthday it is today, your name is? Joanna. Okay, now you know her name. So, ready, set.
Happy birthday to you. Happy birthday to you.
thank you. I would like to explain why we gathered the birthday data. It's a relic of past years. We used to do a probability problem involving birthdays. We're not doing that now. But what I have is this beautiful data set now of the distribution of birthdays across the years. And you can bet we are going to be using that in this, during this term. Okay. I would like to get started on the main business of today, and to do that, I'd like to start with a recall of what we did last time. We ended up last time with the following. We had a population of people, and there were families. Heights were measured of adult children and their parents. And we were trying to do a prediction. If we have a new pair of parents, what can we say about the height of their child, under the assumption that the new pair of parents is somewhat similar to the people that we had before, that they're not from some different part of the world entirely, for example. Our idea for making the prediction was, okay, so we have this new pair of parents, and they have a variable which we were calling mid-parent height, you recall? So they have a number there. Among our data, there were parents that had that same or similar mid-parent heights. So let's just look at that group and look at the average height of their children. And that was our estimate. And we used that idea to develop a function that made that estimate, and then we made that estimate for a whole bunch of mid-parent heights, and what you saw was that you had a scatter plot, and our estimates all followed a line along the center of the plot. Do you remember that? So that is exactly how Galton discovered the regression line. We did that calculation that he did. He did it by hand. We did it using a computer rather faster. But I do have something to ask you. So we'll talk a great deal more about that line and how to use it and how good it is and so on later in the course. I do have a question for you. You saw that it was roughly a straight line through the center of the scatter diagram, yeah? In our development of how we should make that estimate, find the people who look like this new couple and take the average height of their child, was there any assumption that the relationships were somehow linear? So let me rephrase that. Did you see or hear any assumption that the relationships were somehow linear? That you did not. I certainly didn't say it. Nobody said it. And in fact, the reason for that is it wasn't made. We made no assumptions about the nature of the relationship. That scatter plot could have been wavy like a snake. We did not know that ahead of time. If it had been wavy like a snake, what would our yellow dots have been like? Can I see with your fingers? So scatter diagrams like this, and so that yellow line would have been, the spine of the snake. Yes? They're invertebrates. They don't have them. Okay, so it would have been this. And it would have been precisely the same code. And so what is taught elsewhere as linear regression is all the same to us, whether it's linear or nonlinear. You can fit curves through scatter diagrams in exactly the same way that you fit this the line, because there was nothing in our calculation that had to do with a line. And so you actually have quite a powerful technique. We'll be returning to it over and over and over again. What I want to do today is focus on one aspect of it, which is identifying all those couples in our data set who are like this new couple in terms of height. That's what we had to do. What was the method we used to do that? Where? Yes, where, in our old table, where the mid-parent heights are near these mid-parent heights. So we had to do a computation to identify that group. And so also, when you have other conditions that you want your set to satisfy, you are going to have to identify people in your data who are like the people, the new people that have come along. And what you mean by like will depend on the particular problem. So for example, you may be looking at patients and you have a study, and you've done some analysis of how patients respond to different dosages. And their interesting variables are the patient's age, the patient's height, the patient's gender, the patient's blood pressure, previous medical history, lots and lots of different variables. And then there are the outcomes, how they responded to a treatment. So now you have this new patient, and you want to make a prediction of how they are going to respond to your treatment. What do you have to do? You have to find among your data set of patients that are like this one, this new one. So what does like mean? Well, now there are several variables. There is age, there is height, there is previous medical history, etc., etc., etc. So you have to use a measure of distance when there are several features being measured on every individual. And I'd like to remind you of something you've been doing that is exactly this in a much more artificial setting. You recall the successive homework problems on there are 2 universities, and you have features on both of them. In one homework exercise, you had 3 features, and the next one you had 1,000. Remember? There are features on each of them, and you're trying to get a measure of distance between these 2. This is the reason for that. When you have multiple features, how do you say what is close? It's not just one number that you're subtracting from another. It's a whole series of numbers. So you have to figure out what is close and then work with that. So we will be coming back to that idea over and over again. Today what I want to do is I want to just work with categories. So I have people on whom we have measured several individuals, not necessarily people, on whom we have measured several variables, and we're going to try to identify groups of them that share common characteristics. And for today, the variables are all going to be categories, and we're going to figure out how to group people into multiple different categories, and I've used this word, and you have used the same method. There's a method called group, and I want to get into the innards of group today and see how we can use it a little more powerfully than we have done thus far. And so today's entire lecture, there are slides. There are summary slides of the methods. I'll post them, but today's essentially the entire lecture is going to be a demo. So I'll start with, importing stuff. And for some reason, this term, I seem to have an ice cream thing going. So so I bought 5 ice cream cones, and those are the flavors and the prices. Okay. Now, if I want to figure out how many ice cream cones there are of each different flavor, what is the method that I use? Group. That's what group does. It looks down the list of flavors and recognizes that there are only strawberry and chocolate. And then, well, why don't we just do it? The call to group when you're doing this is simply say group by this flavor. Correct? And it does what you can do in your head. First, it counts how many distinct categories are there. And then for each category, it counts the number of rows that corresponds to that category. That's what it's doing. And so now you think, well, okay, so what did it have to do? It had to go through each row, identify the category, and in the end count. So it somehow collected all the elements corresponding to a particular category. Well, if you've done that, can't you use the elements to do a calculation? So if you identified all the chocolate cones, can you not, for example, find the total amount that was paid for those chocolate cones? You ought to be able to. You've got a computer. And in fact, it turns out that group has an optional second argument that allows you to do just that. So I'm going to do it. So we're still going to group by flavor. And now what we're going to do is we're going to ask for the sum. This is a second argument that we haven't used before. Okay, so sum of what? Group by flavor does this. It figures out which ones are chocolate and which ones are strawberry. And what sum does is it sums all the remaining columns. All right, so the only remaining column here is price. So I'm going to run this thing. And yes, I can have all 3 tables there. Could you please take a look and see that you understand what sum just did? For chocolate, sum identified this row, and this row, and then it added up the corresponding prices. Did you get it right? 16.55? Yeah? And then it did the same thing for strawberry. So for strawberry, it added up 5.25 and 3.55, and it got 8.80 correctly. All clear? So this second argument is optional. What you can do is you can use it to compute a characteristic of each category. Now, that is fine. That's how you call a function. You are in an excellent position to get inside group and see what it is doing. So one of the things you know is that you could have really done this yourself. With a table that is so small, you could have done this yourself. And I think what you would have used is where, would you not? First, you would identify the rows that correspond to, say, chocolate. Okay, so let's run that. And you would end up with this. And then you would have to say, okay, so now I have to add up the prices. This thing is a table. It's hard to do arithmetic on a table. If you're going to do arithmetic, like adding stuff up or taking averages or max or something, what do you have to do? You have to extract an array, right? So then how would you go about, which array would you extract? Price. The array of prices is what you would extract. And what is the method that you would use? Column. Yeah. So you would run this next cell. You would take your table and then you would do dot column price. Agreed? And there you would end up with an array of the prices that correspond to these chocolate cones. And now what? Now you sum the array. Okay, so never mind the 0001. I rounded to 2 decimal places. This is rounding nonsense inside of computers. But you can see that you could carry out that process. And what group is doing is it's simply carrying that process out quickly for every different category. That's all that's happening in the back there. And to see a little bit more where this array comes in the group, what I've done is I have put all this together. And what I'd like to do is I'd like to show you what happens when group actually runs this. Ignore the code. You can go back and read it. It's line by line, very easy to read. What I'd like you to focus on is this table here. What group does is it takes chocolate, it computes this array of all the prices of chocolate, and then it applies whatever function you have asked for to this array. I'm going to pause for a second and let you absorb that. So in the end, that function that you are applying is applying to an array. So it better be a function that takes an array as an argument. And so while we're about it, why don't we have a go at another function? If we wanted to find the largest price that I paid for either of these flavors, then I would do cones, group them by flavor, because I'm saying the largest price I paid for these flavors. And then what's the function? Max. And I would get that. And in fact, what would have happened inside is this. Creates the exact same arrays, and instead of taking the sum, it took the max. Okay so far? The reason I'm doing this is not that you will have to construct the arrays yourself, you will just use group, but it is it's good to understand what is going on sort of under the hood a little bit so that you call the right kind of function, right? And so what you understand is you need to call a function that takes an array as its argument. And in fact, way back when we started, we did this basic call without any function. That is actually using a function. And so I want to show you go back and show you okay, hang on a second. I will show you, I just couldn't remember the name of my table. So that is the basis of everything that group does. It constructs that table and then applies functions to those arrays. If you just have that function and you want Python to count how many chocolate cones there were, what function would you apply to that? Len. You would want to know how many in each array. That's len. And in fact, if you use len instead of sum or max, you get the number of cones in each category. And that's what it's doing under the hood. It is using len. It's just, it's a default action, and the display is easily readable. Okay, so that, in agonizing detail, is group. Yes? Yeah, so the question is, these, where did they come from? They came from right here. This is the column of chocolate cones. This is the column of prices of strawberry cones, and throughout. Okay? All right. So just to make sure that we've got that, what I want to do is I want to compute a few NBA salaries. Okay, so you recall this table. There's the NBA salaries for 2015, 2016. And first question for you is, how much money did each team pay for its players' salaries? We've got a computer. We ought to be able to answer this. Please quickly talk to your neighbor and figure out what you have to do. Right, ladies and gentlemen, how many variables are involved in this question? How many variables in this question? Well, so let's read the question. How much money, that looks like a variable to me. Yes? Which column is that in? That's in salary. I've got to use salary somehow. Did each team, there's another one, pay for its players' salaries? We've already got salaries. Yes? Very good idea. Look at what you're trying to do and just extract the bits that you need. You need the team name and you need the salaries. That is the first thing we are going to do. So, okay? Now, so I've got a table consisting of what? How many columns? Just 2. Okay. Now, for each team, how much salary? So you group by what? You group by team, and then you do what? You sum. You add the salaries. Good. So hopefully teams and salaries. Now, dot group. Now, team. First group by what? Group by team, and then do what? Add up everything else, and everything else we have sensibly made the salary. And there you go. You know how much, in millions of dollars, how much each team paid in player salaries. Of course, there are coaches and this, that, and the other as well, but player salaries, that's what you get. Yes? Do you always have to select 2 columns for the table, or do you have to do it on the original? You can do it on the original. Highly not recommended. I'll do it in just a moment. All right? For any data analysis, before you start computing, I implore you to identify the variables of interest, right? So that you can focus and ask an intelligent question on that. But technically you can. I'll do it in just a moment. Okay. More questions? Yes?
So just to clarify, the function part of group automatically does it on the second column?
The function part of group automatically does it on every column that's not the categories. We just have one of those, and so it's doing it on that. The question was asked, what if we had others? Could we do it? We will in a moment, and you'll see why we won't do it. Okay? It attempts to do that on every single column that is not labeling the categories. All right, next question. This one we can do in real time. How many NBA players were there in each of the 5 positions? All right, step 1, identify the variables. What variables are of interest here? Position is clearly of interest, yes? Anything else? Not really. We're counting. Yep. So what are you going to use? You're going to use group with what argument? Position as the argument, because you want to group by position, and then what? Well, then nothing, because it's just going to give you the counts. That's what group does. If you just, that's your old group. If you just give it the this was something you've been using for a while. There you go. There are 5 positions, and last year in the NBA, that there were these many players in each of those 5 positions. Okay? And now if I ask you, okay, for each of these 5 positions, what was the average salary paid? Then what are we doing? We are introducing the salary variable, and we're going to average that, so we have the other kind of call to group. And so we will have NBA dot group position okay, now I have to take why don't I actually select position and salary. Same as what we did before, except our variables are now different. So position and salary dot group by what? By position. And now what I have to do? I have to take an average, and I have to take an average using a function that works on arrays. Recommended function np.mean. Okay? It has to work on arrays. So, work? There you go. The centers were the highest paid on average, at an average of about 6 million per person. Okay, so I'll pause for a second, take questions, because the reason for going through this in such detail was what comes next. Now I hope will become easier to follow.
Could you add the count column to the salary mean column?
You could certainly. You could do with column and throw in the count column as well. In fact, it's funny that you bring that up, because I actually am going to ask that they do it as a default, that you always have the counts. But we aren't there yet. Now, you had asked, what if I try to run this and I haven't selected the columns before? Yep. So let's try to do that. Let's just take NBA and group it by the entire table now. So all the columns, group it by position, and then ask for the mean. Okay, let's just see what happens. That's what you get. It can't take the mean of the players' names, and it can't take the mean of the team names, so it just leaves them. Right? Now, You might have had other numerical columns. It would take the mean of those, whether that made any sense or not. I prefer not to have nonsense staring at me on the screen. So I always just first think about my variables as a data scientist and then do the computation. But does it work? Yes, it works. This way. Answer your question? Okay. So, yeah.
Can you technically drop those player and team main columns?
Yeah, absolutely, you can drop these columns after that. Yes. So if you explore something and you've got a bunch of nonsense that you don't want, you then drop them. Yes. So you can do, these are just tables, and you can operate with them as any other table. You just have to be careful that you're looking at the column headings. All right. So now, this is all fine if you are categorizing by, it was flavor, but here I go with my ice creams again. And I have more cones, and now I have the flavor and the color of the cone. So I have more features than just the flavor. And so now if I want to just run group, obviously it's if I just do more cones dot group by flavor, then I'm just going to find how many cones I have of every flavor. That's fine. But now I can group by both flavor and color. Right? I have two. And so if I think about what does it mean to group by both flavor and color, you can see that chocolate and dark brown is one category. Chocolate and light brown is another category. Strawberry and pink is a category. Bubblegum and pink is a category. So now this is called cross-classifying. Right? There are pairs of categories. And you can ask for grouping by pairs of categories as follows. So you have your name of your table, and now you group. You have to specify which categories you want. Right? And a group needs to know that that's your first argument. Therefore, you need to put that list of categories in an array. And so you will do make array. Okay, we're classifying by flavor and color. Okay? So you specify the list of column labels as an array, and what happened here? Column length mismatch. What is... Hello? Groups. Groups, not group. More than one column, groups. In my text, I have. Notice the plural. Yeah, I should take my own advice. There you go. It lists every distinct pair of categories and counts the elements in those categories. You can see this is just an analog of group. Just now you're cross-classifying by multiple variables. You can find the total price of all of these guys. So you can throw in a function. What do you think that is going to do? There's your table. It's going to group by all of this. I have a sum. What's it going to do? It is going to add the prices in every one of those paired categories. And so let's make sure that it actually does that. Okay? And so now I have used two categories, flavor and color. You could see that I could have done three variables: flavor, color, number of scoops. Right? And then there would have been triples of possible categories, and you would run the exact same code. You would just throw in number of scoops into your array of columns to classify by. Yep? That's all fine. What happens is the more you classify by, the more distinct categories you have, and you have this long table of all these triples and whatever of categories. It's kind of hard to read. Right? You've got this long list. What do you do with all that data? Because you have to work with it. Right? And so one of the things we are going to learn is a method that cross-classifies by two categories, just as group has done, but arranges the data in a more understandable, a more usable way. This is perfectly understandable. What this says is that I paid $4.75 for my pink bubblegum cones. I paid $10.50 for the dark brown chocolate cones, and so on. I can understand that. The thing is, if I want to use that to compare how much I paid for different kinds of cones and so on, it's a bit of a pain. So what I'd like to do is introduce a new method, and my table is called more cones. This is called pivot. And what it does is it cross-classifies just as group does. It does exactly the same thing as groups, but it displays the data in a more usable format. So what pivot does is it takes only two variables. You're going to classify by two variables. The first one, we will choose flavor to be the first one. You can do it the other way around if you wish. And we will choose color to be the second one. And what it did was it took the first argument and made the values of that the columns. It took the second argument and made the values of that the rows. And in the body of the table, in each cell, it put the number of ice cream cones that satisfy both these criteria. So if I look at the two here, I had 2 strawberry pink cones. Did I? Well, groups seem to think so. So what I'd like you to do, in fact, I am going to move this thing down because I don't want it right now. Okay. So what I'd like you to see, we use groups first to count the numbers in the pairs of categories. Then we used pivot to count the numbers in the pairs of category. Please look at this table and this table and recognize that they have exactly the same information. Yes? But what pivot has that is a little bit more helpful, it has all possible pairs, and it points out that you could have had these combinations, you just didn't. It has a whole bunch of zeros. The nice thing is that each flavor now corresponds to a column, and I can compare distributions of counts within flavors. I can compare distributions of prices within flavors. And so you can use... Actually, I'm going to pause for a second. Okay. Questions thus far about pivot? Can you perform sum on each of the columns? This is a table. You can do any operation on the columns that you can. And so what I will be doing, if I have time today, is I will be converting sums to the numbers to percents and comparing distributions. Right? Not with ice creams, but with something more interesting. So the point of pivot is to get the data organized in columns so that we can actually use them. And so what I would... So if I run this again, and what you'd love to be able to do is get prices and stuff as well. So you can do that. Now, you see, it's going to put something in each of these cells. It needs to know what you want to put in there. What I want to put in there is price. Not how many, but how much did it cost. So I have to specify an option called value. And that's the name of the column that has the ingredients that I want to put in those cells. Now, of course, in this cell, there are 2 prices. What I need to do now is tell Python what I want done to those 2 prices, and I'm just going to ask for a sum. So what I'm telling Python is how do I collect those values? So the argument is called collect. And I'm going to say collect them and sum them up. Before we run that, are the arguments clear? Price contains what's going to go into the cell. Collect says what do you do to those prices that are in each cell. And if we run this, what? Values. Okay, I'm having trouble with my plurals today, sorry. Right. Questions about what's been shown in this and how it relates to the code. Clear? You can read what's going on there? Okay, so pivot. What does it do? It cross-classifies according to 2 categorical variables. That is a mouthful for it cross-classifies according to flavor and color. You can't do it with 3 because you need an axis that's coming out at you and hitting you on the nose. Right? Just 2. That's a very common situation. This is also in statistics known as a contingency table. So it cross-classifies, and then in each cell, it groups values by that cell and then performs an operation that you ask for. Okay. All right. So the first column, the first argument gives the column labels. The second argument gives the row labels. Values gives which other column you want organized in the cells, and collect says what you want done to those values. The question here was, what if I just specified values and didn't specify the collect? Yeah, that was the question. Shall we run it? I think we should run it. That's what you want, yeah? Okay, here we go. Not happy. Not happy. If you're going to specify values, please say what you want done with them. So going back to our happy place. Okay. All right. So now I have a few minutes. Okay. I have a few minutes to at least introduce a more interesting example than these wretched ice cream cones. Okay. What I attempt to do always in a lecture is to do an example with a small data set where you can exactly see what the answer ought to be. And then when we are convinced that the program is doing what you want it to do, then we move to a big data set where we have no idea what the data ought to be. Okay, so I'm going to, here is a data set. Okay, this is just the output of groups that we had before. Okay, let me show you a data set. This is the state of California in the year 2014. Data provided by the Current Population Survey, which is an arm of the census. And the population of California has already, the adult population of California, 18 and over, has already been classified according to multiple different categories. So age, gender, educational attainment, personal income. And then for each of those very detailed categories, there is a population count. How many in each of those categories? So as you can see, in the entire state of California in 2014, if you look at adult females who have no high school diploma, and you count the number who are making $75,000 a year or $75,000 or more that year, you end up with only 2,000 people. Yep, that's not a lot of people. And so, you have counts here, and I look at that, and it's wonderful that I have all these data, but I can't make head or tail of it. Because there are how many categories? There are 127 total categories, right? And there are counts in all of those. I don't know what to do with those. So we're just going to focus our attention on 2. I want to look at the relation between educational attainment and personal income. Okay? So to do that, we are going to select those columns. And of course, I want the population count in those categories, so that's my sub-selected table. Yep. And what I would love to do is get some sense, before I look at the relation between 2 variables, I always examine 1 variable first. So what I would love to do is get a sense of the education distribution in California, right? What is it, because I don't know. And for that, what do I have to do to this table? I have to group that table by what? By educational attainment. That's what I have to do. And that will simply return to me the what? Well, so I have to group by educational attainment, and then in each category, what do I want? I want the total number of people. Yep. So what do I have to do? I have to sum the population counts. Yes? And so what I have done here is I have done what I always do, which is I have selected just the columns that I need to answer this question, which is educational attainment and population count. Yeah. So you can see that no high school diploma appears on many rows. So there's no high school diploma earning this much money, no high school diploma earning this much money. So if I need to know how many Californians have no high school diploma, I have to add these guys. And so I create a table that has just these 2 variables. And then I call group on that table, grouping by educational attainment and taking the sum. So before we run the cell, questions about why that method and no other, okay so far or not okay? I prefer not to have a whole snowballing issue here. Okay, so I'm just going to do this and look at the table that I get. And I get this. So in fact, there are only 4 categories of educational attainment in this table. For all that there were 127 different categories, educational attainment is a very simple variable in this table. There are only 4 categories. And this is the total number of Californians, adult Californians in each of those categories. That's what I have. Okay? Now I look at that, and that's lovely, but I can't make head or tail of it because I don't understand those big numbers. So what is a reasonable thing to do if you want to see what the distribution looks like? Percents, proportions, those are exactly the right words to be using. Do you remember last time we defined a function that converts an array to a percent? So I will bring back that function and its definition. This was our function, recall? We spent some time talking about that one. So I'll define that function again. And then what we will do is we will call that function on this array of population counts. So what I'm doing here is I am creating a new table, which is the old table with an additional column, which is population percent. And what that is it's the function percents applied to the old table, column 1. And if I do that, I have now converted the counts to percents. And now I understand what's going on, right? Almost 1/3 of adult Californians in 2014 had a bachelor's degree or higher. And almost 16% had no high school diploma. So we are quite a varied state. Okay. Yeah, it's column 1 of my table because I selected just 2 columns. Yes? And so this is column 0, this is column 1. So you could write population count in there and you'd be fine. Okay, so now I want to look at the relation between educational attainment and income. And so we have different levels of educational attainment, we have different levels of income. I want to see how many people were in each pair of categories. What do I use? I could use groups or I could use pivot, right? I will just use pivot just to see how that goes. Okay, so I need to call pivot on my table and specify the 2 columns. Then I want to count the values. And so the values are in population count, and what do I do to them? I have to sum them up. Yep? Okay, so I collect all that in a table, and I and so now you have these many people had a bachelor's degree or higher and made this much money, right? These many people had a high school degree or equivalent and made between $15,000 and $25,000. That's what I have. Yep. Well, I don't understand that any more than you do because it's a mess. So what am I going to do now? I'm going to assign all of those are going to become percents. So I'm going to create a new table that has this column, and then instead of these counts, it just has percents. Right? And so I'm applying percents over and over again. And that creates a table which I am calling distributions, and that looks like that. So, bachelor's degree or higher, 35% are at the highest income level. No high school diploma, 1.38% are at that level. And if you draw the bar graph, looks like that. No high school diploma, low incomes. Bachelor's degree or higher, high incomes. Right? So John will come and play more with this at the start of Monday's lecture. It's in the textbook. Somebody had a question, yes? You can certainly use apply. I think it's overkill because the same thing is being done to every cell. You don't have to look at the value in a cell to figure out what. So you can use apply.